Okay, so after I did the problem, I started to think about it, and that's one of the things that you should be doing when you're doing a problem, not just finishing it, but thinking about it. And I think it's a good question. And what I mean by that, good question, but it did cost me some issues that I had to think through. And it says, over here, between what two angles, I guess I should pluralize that, is the leaf formed. So what I want to do is I want to talk about what the leaf looks like to me. Right, so the first thing I want to point out is what the leaf looks like. It looks like this thing over here. Right, so what I got to discuss is when does that occur, between what two angles? Like if I want to compute the area of this thing over here, I would have to say, oh, I wonder what two angles that leaf occurred between. Let me get my eraser out. And I'm glad I have a picture because it's make it a little bit easier for me. And the first thing I'll do is just put a line here. And I'm going to say, it definitely, if I thought about this thing, there would be an angle theta here. And the theta here, just looking at the picture, by the way, that I know it occurs, right, just tracing over here, right over there, all right? So I got a general idea that it occurs between 0 and pi over 2. And what's the equation? R equals, I'm going to talk about the R now. What's that going to be? R equals 3 minus this given theta, all right? So then the question comes is, when does it come back at itself? And it keeps whipping around. And what I want to point out, the next time it hits it is when this thing becomes minus R. All right? Question is, when does that occur? Well, you kind of look at it, and what do you see over here? Well, I have to keep going. And how much more do I have to keep going? Pi. All right? So when I go forward, it's going to be minus R eventually. And that means whatever's over here is going to pop back over there. It's going to be 3 minus, let's be careful about this, it's going to be theta, right, whatever that angle is, plus pi. I have two equations, two unknown. My goal here is to find out what the theta is, and then make sure the theta is between 0 and pi over 2. So add them together, you get 0. This will give you 6. 3 plus 3 is 6. Minus theta, minus pi. All right, let's keep going. And what do you see here? Well, I write down 0, 6 minus pi, minus 2 theta. I'm going to add the 2 theta to both sides, and I get 6 minus pi, and theta would be 6 minus pi over 2. Right, I know what the theta is. Now, is that theta between 0 and pi over 2? Let's write this down. Multiply all sides by 2, you get 0. 6 minus pi. I'm going to add pi to all sides, and what do you get over here? Pi, 6, and 2 pi. 6 is certainly greater than pi, and 6 is certainly less than 2 pi. So I'm pretty comfortable that I know my angle theta now, all right? So where does the first time it hits? Let me put this down. There's going to be an interval now. It's going to be 6 minus pi over 2, comma. And the question is, what's the next angle? Well, remember, we just discussed it. It's going to be theta plus pi. Let's write that down. So 6 minus pi over 2 plus pi. And that's going to be 2 pi over 2, which would be 6, let's see, minus pi plus 2 pi is just a pi over 2. So if I want to get the area of that leaf, let me get my eraser out. This is a tough problem, but I realize that. If I want the area of this leaf over here, right, the area just of this part over here, the leaf, I call that the leaf. What I have to do? Integrate the function, right, on the interval here. All right, let's just check the key and see if I wrote that down for the interval. I did say it takes a bit of thinking, and I'll be honest with you, it took me some time to think through it. Got this over here. Sometimes I get confused when I'm thinking, but that's fine. I try to resolve it and try to think through what I said, premises and things like that. And 6 minus pi over 2, 6 plus pi over 2. All right? we're good to go. Thank you.